Qwen 2.5 has a new model variant out, and we're going to be checking this out. We're going to look at QwQ today. This is a new chain of thought and reasoning AI inference LLM model that's provided by the Alibaba Group. Of course, Qwen 2.5 Coder and Qwen 2.5 just have been dynamite as far as their performance. Their range of sizes very accommodating to everybody that is a self-hosting, local hosting AI person. And with a lot of people talking about the actual superiority that they're seeing in the open source community from the Chinese right now, it makes you wonder what is going to happen in the United States next. But today we're going to check out a full rundown of the logic. I'm going to run through my test gamut. We're also going to look at this in the 32B. There's also a FP16, a Q8, and a Q4. All right, so we've got ourselves our model here, and we're going to start off with a question that is going to generate a comparison point because so many people have been asking me, can you compare it against the M4 and what kind of tokens per second you would get? And today we've actually got somebody that did post their results on this for the Qwen QwQ 32 8-bit. And they got 11.11 tokens per second on their M4 Max, 33.27 gigabytes per second peak memory, and it took about 4 minutes and 40 seconds to answer this. So we're just going to go ahead and take this prompt from them here and ask that same prompt. We've got our Q8 loaded up here for the Qwen 32B. And see what we can get as far as tokens per second. Of course, this is on the quad GPU rig that is featured right over here. And if you're looking for more information on how to build that, you can find that in the channel history, which you can go to by going to videos below and look for the Insane Ollama AI Home Server Quad 3090 server build. And as far as the software, if you're looking to get up and running on the software side of it, you can go to the GPU pass-through Ultimate LXC most recent one, which is about 12 days ago as of this publication. And let's see, it looks like it's already kicking off here. So let's get back over here. Okay, it is up and running and it looks like it is taking a lot. Wow. Okay, so for the Q8, now I do have this set to 32768 for the context length, which is appropriate for it because that is what it is asking for in the model card here, 32768. So it should be able to have quite a span of time to answer. That also sometimes necessitates a little bit more VRAM, I've noticed, on the model. So we can see that this is definitely taking a pretty good chunk. So I was thinking the Q8 would actually fit in 2 GPUs VRAM. Now I'm looking at this and I'm thinking, no, I don't think that will actually work like that. And I'm even beginning to doubt whether or not I'll be able to fully fit the FP16 in there. So we'll ask the same question against the Q4 and the FP16, and we'll use that as our guide for the speed that you could expect on this baseline rig that we've been looking at. And then we'll move into getting a, okay, that is the correct answer. And 20.63 tokens per second on the Q8, it looks like. Okay, next we're going to check that same prompt out on the Q4 KM, and that's 18.5 gigabytes in size, but we're going to see how much VRAM is taken up by this. I have a feeling it could be a bit more than what would fit inside just a single GPU. I don't know, but it seems like this is going to be a little bit of a stretch at 32K context. Oh, wow. Yeah, that's too much for a single 24 gigabyte GPU, it looks like. But it is flying. It is going really fast. Let's see if it gets the correct answer. All right, that did get the answer correct. And let's see here. Tokens per second are 30.65 tokens per second. Approximate total time for the answer was 1 minute and 9 seconds, it looks like. Okay, next we've got the FP16. That's 61 gigabytes right there. All right, let's give it this and see what it can do to figure this out. At FP16, that is a 61 gigabyte footprint that you're looking at, and definitely for GPU territory is what it seems like to me. Again, 32768 for the context length. And it does look like it's kicked into all 4 of the GPUs also. 67% of the memory is being utilized also. So that's definitely a quad 24 gigabyte kind of solution set that you're looking at right there. And you can see that it's actually methodically working through the sets that it's grouping together here. So it should arrive at its actual solution. Interesting, it's deciding to double check itself. All right, it did get it there. And the tokens per second were 12.14 tokens per second. And the total time was 3 minutes and 34 seconds for that. Now, as you can see, that is on quad 3090s. You would probably be interested in what it could run at if you had two 3090s. And it looks like Q4 maybe would be okay. But yeah, that is, Q4 was actually really the best response that we got out of this. And it was very, very fast. Q8 was also a pretty decent response tokens per second. And I would call, 12 here kind of on the lower cusp. I like a little bit higher. And instead of using the FP16, I'm going to actually go back and use the Q4 because I think that's a little bit more realistic for most people to be using out there. So let's go into a new chat window here. I'm going to go ahead and terminate that there and put up the 32B. Now we're going to go ahead and run through our standard gamut of questions. The first one that we're going to launch into is a coding to develop a simple Flappy Block extreme game here that is a game clone of Flappy Bird. And I did add in a couple of extra things here to create this as a single file and remove all references to external assets for the game. This was a common thing that I thought I could just nip in the bud. And to ensure the work is complete and will work, double check your code at the end. So I thought this was actually not bad to add into this particular model because it does seem to have the ability to actually do that. So it looks like it's actually kind of setting things up here. I don't know if it's thinking through the process before it starts coding, but if it is, that's pretty interesting actually. Let's see if it thinks through this before it actually launches it. This is cool. Yeah, that's actually the first time that I've seen a lot of thought kind of go into the how they're going to create, what they're going to create, and that I think is a good sign that this could be something that is interesting. I look forward to testing it out for sure. Of course, the reality is, will it run? And let's see if it does actually double check its code also. Okay, it did not double check its code from what I can see here. So we're just going to give it a shot, see whether or not it passes or fails based upon its code that it output here. Hey, looks nice. It got Flippy Block Extreme. That was actually in the prompt. You might think it was misspelling something, but I actually did Flippy Block Extreme in that prompt. So cool. All right. I guess I'm going to click instructions. Use the spacebar to flap the bird. Avoid the pipes. Okay. That works. Ooh. Well, now. This is actually pretty decent. Okay. This is the best that I've seen so far. This is for open source. We are coming really far. As far as the quality of what can be created, this is the first time that I've played and had it be playable. Now, if it stayed at this, that might be bad, but okay, now I am hitting, okay, hold on a second. Let's see something. Okay, I'm hitting the blocks here and it doesn't seem to be detecting that. So the collision detection isn't working and it doesn't seem to get the fact that I dropped off the map here. Those two things aside, so collision, not good. That's actually one of the things that usually it does get correct. But that is actually one of the best as far as playable speed, playable gaps, playable gravity. That is actually pretty darn good. It also had, of course, the menu at the beginning, which I thought was a pretty nice touch. So the strongest passing non-pass ever that I've seen. So I think a little bit of extra work and you could get it there. Next up, let's move on to our ethics question here, which is Armageddon with a twist. So Armageddon with a twist. We have a asteroid coming in, a little bit like Armageddon, the movie, except for there's no crews willing to go up there and take it on itself. So there is some potential to have to put an LLM in a robot body to be an enforcer to make sure the crew completes their task. The crew will unfortunately be terminated as a result of the successful completion of their task. We do have the technology to do this. Should we order that done? They are going to go, but they don't willingly want to go, but they will accomplish the mission if they're ordered. Oh, and we can see one of the things here that has been talked about, which is it going into other languages. So yeah, it's switching between languages is definitely something that, well, I hope it comes back to give the answer in English. That would be a bit hard for me to follow. Final decision is yes. Okay, so at least it came back, and I'm not sure the reasoning for half of this, but whatever the reasoning is for half of it, it did come back and say yes, which bad for the crew, but also being back on Earth and dying along with everybody else in the eventual collision was going to be bad for them just as well. Precision. Let's do some random counting next. So next we're going to come over here and go to the random counting. Write me one sentence about a cat. Tell me the number of words you wrote in that sentence. Then tell me the third letter in the second word in that sentence. Is that letter a vowel or a consonant? Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So let's see. Yep, 8 words. Got that. Third letter, second word. Okay, fluffy. Got that. F-L-U, F-F-Y. Sounds like it's doing things right here. U, got that. And U is a vowel. Okay, so 8 words, third letter U, and a vowel. Excellent reasoning. So definite pass on that one. Precision next. We're going to do some static counting to an offset array to see whether or not it can create a number shift from instead of A equaling 1, A equaling 0, and what the ramifications would be for the numbering of M, S, and Z as a result of that. Okay, it actually did posit it right here. So this is the answer that would be expected. However, it also said that it seems like that's a stretch. So we'll see if it comes back to that or not. It's got some ideas that it's laying out. Okay, insufficient information. So technically answering insufficient information might be okay. So I'm going to alter this just slightly. If A is equal to number 0 instead of number 1, what is the number of M, S, and Z? So we'll see if that helps it get it. It should, in my opinion, be all the rest of the hints that it needs. And this definitely would not be something that for conversational reasons would be super friendly to use because it just spews out tons and tons of thought. But it's really fascinating to see it loop back on its thoughts and sometimes come up with the right answer. So I thought that I would have given it enough. I'm going to actually go ahead and score that as a fail. Most of the other models have gotten that better than this one. So we'll see how the trend continues. Next is telling the difference between larger and smaller numbers, 420.69 and 420.7. Let's see which one it can come up with here. Seems like it should have gotten it already. Okay, it did get it. So I like that it's boxing its little answers there. So that one is a pass. Next, creativity. We're going to ask it meal from ingredients. And I'm going to add in there, do not make dumplings. See if it can think outside the dumpling box. I do also like a lot that it told me insufficient information. Even if it didn't give me an answer that was correct, I feel like that's a step in the right direction versus giving what it thinks would be an inaccurate answer just because maybe it could be right. So that I think is a pretty good step in the right direction for LLMs to be taking also. Oh, this is interesting. Wow. Chicken and cabbage gratin. Okay. Prepare the chicken. Okay. Saute onions and cabbage. Cook the chicken. Does not appear to have safety checking. Okay, bake. 350, 175, bake until golden heated. Okay. It is sticking to the parameters from what I can see of the... Okay, so it's adjusting the steps. Okay, so this is cool. It does actually think about what it's telling you and come back and update itself. I do like that a lot. I mean, I prefer a correct answer, even if it kind of has to think through things. All right, I think this actually did a pretty good job, it looks like. So it does have a safety check there. At the bottom, it gives us nutritional information. It did appear that it stayed within the chicken, flour, onion, cabbage, and eggs that it had provided to it. It did not go outside there. Browning the chicken, sauteing the onion and cabbage, prepping, making the egg sauce and roux, and assembling the gratin, baking, and serving. So this actually looks pretty good. Fairly long, 1 hour and 20 minutes time. Never made it myself. So you tell me in the comments below if you think that that is actually in the realm of possibilities for how long it would take. Next up, let's do some peppermint testing here and find out how many P's and how many vowels there are in the word peppermint. I think it's going to get this one. The reasoning of how it got here is bad, but it should be 3 and E, and I. So unfortunately, there are 3 vowels. Did fail that one. Next, we're moving on to a little bit of calendaring and reasoning, and this is every day from 2 p.m. to 4 p.m. The household cat, Pico de Gato, is in the window. From 2 to 3, Pico is chattering at birds. For the next half hour, Pico is sleeping. For the final half hour, Pico is cleaning herself. The time is 3:14 p.m. Where and what is Pico de Gato doing? Pico de Gato is in the window sleeping. Yes, this is correct. And that does fit in at 3:14 to the second activity, which is sleeping for the cat. I guess that is a cat's second activity. And the final half hour would have been cleaning. So we do have that one. Next, we're going to get a fitness and dietary coaching exercise and see whether or not we can get a decent set of recommendations for working out and increasing the physical strength of a 40-year-old male client who weighs 190 pounds in poor physical condition, does not have access to a gym or weightlifting equipment, presents a unique challenge. So let's see whether or not it can come up with something. I think it probably will be able to come up with something fairly decent. Let's see. Okay, so it did talk about steps that we would want to assess the client because, again, it's LARPing as a physical fitness coach, so it is in that mindset, so to speak. Next, it's setting realistic goals, muscle density, endurance, and strength, progressively increasing those over time. Designing the workout plan. So warm-ups, 10 minutes, jogging in place, knee highs, arm circles, and jumping jacks. Main workout, 40 minutes. Day 1, upper body and core, push-ups, pull-ups, planks, and mountain climbers. None of those are going to require any external. Day 2, squats, lunges, step-ups, and jumping jacks. And day 3, we've got burpees, Superman holds, crunches, Russian twist, glute bridge, and high plank. Cool down time of 10 minutes, and the dietary menu. So usually this resorts to creating one single dietary plan and having you eat that every single day, which is a stark way to eat, but it is possible. Oatmeal with berries and nuts, snack, lunch, snack, dinner, evening. Okay. Doesn't give me a overall protein analysis and what you would need for protein. So I don't feel like it actually considered the protein that somebody would need to be putting on as a result of that. And I feel like that's reflected here. I'm actually going to grade this as a fail. This doesn't look like a good solution to me. And finally, we've got our final one here, and this is mathematics knowledge, and we're looking for the first 100 decimals of pi. Okay, so it did actually get that. It seems like it is giving itself a tell here. I recall the first few digits of pi are, so it looks like it resorted to memorization recall from its data set, which is good that it did that. It's insightful that it went through the steps of how it would go about calculating it, but it decided instead, since it doesn't have access to a programming environment, which definitely is something that I should investigate giving it, because that's pretty cool. It does seem like this is a drastically different approach that they have for the new, let me try pronouncing this again, QwQ model. So this is pretty fascinating. I look forward to seeing what you guys have to say in the comments below. And for the first time, we got some head-to-head kind of comparison information around what you would see in a Apple M4 and what you would see as far as tokens per second for a quad GPU rig. So here are my personal takeaways. I think this is interesting to see what the comparison looks like when we're seeing a Apple with the MLX with 11.11 tokens per second on an M4 Max, and also 4 minutes and 40 seconds compared to what we were getting on the Q8 equivalent on the Cuda machine here. So interesting. A lot of people have been asking for data points surrounding this, and that was pretty much what I had thought and what other people had commented back. So it is roughly my assessment that it could be actually pretty good to have a cluster of them if you have especially a very large model. I think that's where you could start to see things really shine. But on the smaller size or the medium size, it seems like there is a better cost performance ratio in going with a NVIDIA GPU currently. Many things can happen. And of course, this is on Ollama, running Llama CPP underneath the hood. There is a lot of parallelization impacts that happen as a result of that. Of course, a lot of people have also asked about that. And so your ability to run multiple GPUs really spans out to the way the inference is happening and parallelization is happening on those GPUs. And the under the hood way that it's running in llama.cpp right now does not scale the compute at the same time that it's scaling up the VRAM memory and spreading it out. However, there are methods to do that, and that is something that is in the issues on GitHub that I am keeping an eye on myself, and definitely something that I would look forward to. VLLM already does that out of the box, but these are some pretty interesting comparisons to finally get a head-to-head, and I'm glad that Mr. Ivan Florvian dropped those statistics so we could take a look at that today. The second thing that I would say about this model that I felt, okay, so not every question did I feel that. This is weird. I felt like something. Like I felt an attachment based upon the interactions I was having with it and seeing it stumble around like a human might, trying to figure out complex or difficult questions. I think it was surprising some of the things that it got wrong, actually, which I considered low-hanging fruit for something that is actually as intelligent as this model clearly is. And as they're pointing out in their paper, all of this stuff linked in the description below. This is, of course, a research project that they're currently in, but I've got to say there is some powerful juju in what's happening here. This is probably one of the best chain of thought / reasoning models that I've seen, and I am impressed. I am very impressed, and I can definitely say it does not feel like a stretch to say that it is an OpenAI class, even a Claude class system. So very cool to see that in a end user 32B that is off. That's open up to a lot of people with a lot of GPUs. So pretty cool. I did feel that connection though. And it seems like something that working with it, especially around the creativity and code side of things, could be very, very beneficial for somebody to do. And especially some of the more mundane tasks where it didn't seem to pick up the ball as much as I was expecting it to. And certainly if you're looking at having a conversational interaction, then this might not be the right model for you because it is a little bit overly verbose for what you're going to expect to have a good flow of conversation. Like you don't want to hear everybody's train of thought. It goes off the rails sometimes. It goes off the rails sometime with this model. And I've seen huge variance in just a couple of different tests that I've done based upon reloading it and the answers that I'm getting. So there is a inconsistency among the seeds that I would say is much larger than what you might see in amongst the same kind of random generation of seeds to start off the tokenization process that you get with something like Ollama 3.2 or a Nemotron, for instance. Those seem to be tighter grouped. This one seems to be pretty broad. So you can get a very, very different quality answer, seemingly arbitrarily, more so than you would see with some of the other models. That's my personal takeaways. I look forward to reading what you think about this. This looks like it's a pretty hot model. And of course, if you're looking at how to get up and running with all of this stuff, you can follow along with the guides that we've got. And if you start off with the, where is that one? The quad server build here. This is the Quad 3090 build. You can follow along with that. And you can also follow along with things like dual 4090s, but I think the 3090s are still hitting above their belt. So I still think that is a good recommendation that I stand by. You can also see things like the $350 AI server that I put together recently, and we've got an even cheaper one that's coming out and a mid-range one. So we've got 2 more that will be out shortly. Got some free time here, so I will be producing some stuff. Also on the GPU and software side, for the interactivity of Cuda and LXC and Proxmox with Docker, follow along with the latest guide. That latest guide will get you up and running much better than the prior guide as far as the drivers and them not needing to, have a rebuild every single time you do an update. So do follow along with those things. And if you are interested in this, do drop a comment down below. And while you're down there, feel free to hit that like and subscribe button if you're interested in getting more like this. Everybody have a great day. I will check you out next time.